Hi, this is my ALU circuit. So when selection 0 and selection 1 are off, then Y is going to be equal to the exclusive OR of A, B, and C in. So when one of these is on, then the LED should be on. So we have here, one of them is on, the LED is on, 2, LED should be off, 3, the LED should be off. We have 1, the LED should be on, LED's on, LED's off, so that works. And the way that works is these three go through this XOR gate, A, B, and C, and all go through this XOR gate right here. And then they are allowed to pass through because of this buffer. This buffer is activated by this right here, which is the and of the inverse of selection 0 and the inverse of selection 1. So that's on. This buffer is on, so whatever is here will pass through to the LED. So then, if selection 0 is still 0 and selection 1 is 1, then the LED should be equal to the NAND of A and B. So when both of them are off, then the LED should be on. But as soon as one of them is on, or no, my bad. When both of them are on, the LED should be off. But in every other case, it should be on. And that works the same way as before, where, we have our AND gate, which is going to be on when selection 0 is 0 and selection 1 is 1. Goes up through here into the buffer, so only this input right here is going to be allowed to get into Y, the LED. And yeah. Alright, so then we have selection 0 is on, selection 1 is off. And when that's true, we're going to have the XOR of A and B. So here's the XOR of A and B, here's the buffer. So when one of them is on, it should be on. When both are off or both are on, it should be off. That's demonstrated behavior. Alright, and then when they're both on, we're going to have the output here. Buffer's activated. This is a NOR. So when they're both off, that's when we should have it on. But as soon as A is on or B is on, then the LED turns off. Right. And then down here we have our C out input or output. Right. So this only matters when selection 1 and selection 0 are both 0. So instead of having a buffer like we have over here, it's just always going to be equal to AB plus C in of XOR AB. So basically we have the AB, so we have not AB right here, comes down, put it through an inverter. So we have AB, and then over here we have XOR AB, come down through an AND gate with SYN, and then we have it go through an OR gate. So if A and B are both on, it should be on. Or if one of A and B are on and C in is on, then it should be on. And that works. So thanks for watching. One thing that I thought was kind of tricky about this is this XOR gate. Because like sometimes XOR gates are, it's an exclusive OR, so sometimes it should be like, all right, if only one of them is on, then it should be on. But it also can be sometimes used as like a parity, so I wasn't sure if I should stack these, so it'd be like an XOR gate here and another XOR gate, two input XOR gates instead of one 3-input XOR gate. And if I use two 2-input XOR gates, then it would be like an odd even. If it was odd, then it'd be on. If it was off, then it was even, it would be off. But instead we used the 3-input XOR gate, which is only on when one of A, B, or C and are on. Thanks for watching. Hope you enjoyed it. Yeah.